Hello, hello everybody. Let's see if we are live. Mm, yes, we are live. I'm going to throughout this tutorial, as I said early in an early life. I'm not pretend to do all this. It's too much, and you don't need to know for upfront all the things, but the basics are always a good thing. We are in binaries, strings, and char lists. I just read this 15 minutes ago because it's quite a different approach to this data type in Elixir, and I don't want I didn't want it to be like a reading. Okay, binary string and char list, and they say we have strings. Let us open this, and you have a string. Hello. And they say that the strings are a sequence of bytes, contiguous bytes, called binaries. So this is their notation, binaries. Mhm. Look at this, it's binary string, binary string. It's just some terminology they are using. For them, they are a sequence of bytes, contiguous bytes called binaries. And short list, okay. Unicode and code points. Unicode is standard. There is a link over here which you can read. Okay, to encode characters. And then you have the concept of code point, which are like indexes. Here it is, numerical indexes known as code points. That's how Unicode organize all the characters. And you can request the Unicode value, the code point for a value with this question mark. Let's put, and they are not enclosing the character in single quotes. You see, just the at and the question mark, and it gives you 64. You know, uh, yeah. I suddenly I just see that I can use these too because my keyboard is lacking some symbols. All right. We refer to code point by hexadecimal numbers. So you have this Unicode and its hex value. But remember that hexadecimal has 0x, so 0x and 0061, which is here, but in here they are using the inverted slash u. And you know, they have this reference, which is great. I'm going to save this. UTF-8 and encoding this. Okay, now we are here. Again, we saw this at the beginning of our first session, live session. So the length of the string is 5. Hello. So the byte size is 6. Why? Because this requires 6 bytes. And it says something about if you're running if you are running Elixir in some other operating system, And the notion of graphemes, I didn't want to type this. You can copy paste it. We can copy paste it because how can you type this? Look at this beautiful, and you have a beautiful princess fighting the fire. However, Elixir is smart enough to see this as a single character. The length of this grapheme is 1. But its code points are 3. And it says something like it's everywhere. If you want to see the exact bytes that a string will store in a file, common trick is to concatenate the null value to it. So this concatenation operator, it works with this. Okay, null byte is being called. What? What do you think it will happen? It will happen if we put this at the beginning. I'm going to copy paste this because how can I type these symbols? You know, I don't know what these symbols are. So yeah, and it seems like it works too, whether at the end or at the beginning. So you can prepend or append, and you can inspect also which accepts two arguments in the string and as binaries. Uh, this syntax is being explained in a future lesson. And then we arrive. So I'm not sure if this is clear for you. It's just terminology for them. These are binaries, a sequence of bytes, contiguous bytes, and then we have code points, the standard encoding, the graphemes, the concatenation operator operating on a string, and on this null byte, this function. Now we arrive to this string. Bit string, another terminology, fundamental data type in Elixir, denote by this syntax. So this is a bit string, and supposedly this is a bit string, given this nomenclature. And it says it's a contiguous sequence of bits. It's different. The binaries are bytes, contiguous sequence of bytes, and the bits, and these are bits. By default, 8 bits, 1 byte. Okay, but you can manually specify the number of bits via this operator modifier. And so you can use this declaration too. And you have this bit string 42, and in here is the same bit string, but you are specifying, you're being explicit on the number of bits. By default is 8, but you can use another one. In here is 4. Okay, I suppose this is some kind of low level. It says something about Erlang interaction. If you are programming applications, I'm not sure if you are going to be writing a lot of this unless you are. It seems like low level, right? not something that you do on a daily basis. I mean, for an average application. For example, the decimal number 3, when represented with 4 bits in base 2, uh, will be 001, 001, 1, 1. Okay, do you get this? This is the value, and this is the size. Where is it mentioned? The number of bits. You are specifying the number of bits with this modifier. You can go verbose with this explicit. So you have the value, and you're saying that you're only using bit, one bit to store this value, which is 0. So you have 0011, 0, 0, 1, 1, and you are using one bit to store each one of them. And you are asking if this is equal to the number 3 represented with 4 bits, and it says true. I'm going to copy paste it. True, and then we clear the screen. We come in again. Now, what happens? What happens if you want to represent this tree with 0 with 8 bits? We will have 0, 1, 0, 1. Can we do that? It's kind of tedious. Let's see how it goes. We will have another 4 of these. I'm going to copy paste this. 1, 2, 3, 4. Zero, 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 1, 1. Let us see if we don't hit ourselves, shut ourselves on the foot. How is the says? How is that all saying goes? So the default is 8. I'm not sure if this is going to work. And it says 3, but we are not using the equals equals. So let's use the equals equals. Oh my god. And it says true. Okay, you got this thing under your belt. And if you are going to use more bits, then you can prevent. You can go explicit with verbose with size 4. Size 8, which is silly. And it says true. Okay, I hope that helped me to understand this thing. Any value that exceeds what can be stored by the number of bits provision it is truncated. So if you are storing is 1 this bit with 8 bits, this bit string stored with 8 bits equals to 257, it says yes. Why? Because remember your thing, 2 to the 8th is 6. 256. And you got some kind of overflow. I don't know. And you have this beautiful binary number. Imagine living in 1940 and having the opportunity to write the first programs in, to work with binary and see the computers back then, big machines, how things really work. Right now, there is a lot of abstraction. I'm not sure if that refrains us to understand on a deeper level computers. I would like to, if you know some learning resource or a book uh, explaining how things were made in the past only for self enrichment, it would be like some book, for example, from electricity, from I don't know, some how you can produce a spark. Problem being nonsense, naive here from the electricity, but something that you can see the entire journey from that until right now, in which a computers can do object recognition, speech recognition. That will be great. But the greatest part, the beautiful part, will be this is amazing to this latest progress. But I think the core, the beautiful for me will be seeing these things. All the progress that we have made. I simply want the reference for bit string is here. You click and you see these examples, and the constructor it accepts arguments. I'm not sure if this args refers to the fact that it accepts a variable number of arguments like this. Not every bit. Okay, and here you can use some binary. In here you can, exercise some kind of logic if you are into that. A binary is a big string where the number of bits is divisible by 8. That means, here is the reasoning part. That means that every binary is a bit string, but not every bit string is a binary. You can spend, I suppose, 6 hours thinking just on this phrase and this statement. Every binary is a bit string, but it's a binary. Remember, your strings contiguous sequence of bytes is a bit string, but not every bit string is a binary. And you can spend some hours thinking of this and making some exercises on your notebook. I will not do that because, a binary is a big string. A binary is a bit string. Just see that, where the number of bits is divisible by 8. And you can go ahead and say, I want to write a program which is already written. Look at this. This is your proposed program. Is bit string, is binary. You can tackle this by yourselves. We can tackle this by ourselves and say, okay, I'm writing it's bit string and accept the argument, and I'm writing is binary, just to have fun, I suppose. And again, you have functions in Elixir that helps you with with task, and you ask, is bit string 3 represented with 4 bits? And it says true, and then it says is binary 3 represented with 4 bits, and it says false, and it continues. And in here they are prepending this 0. Okay, this is too much talk instead of code. I'm sorry. There are only 20 minutes. And you can use your beloved pattern matching. I'm not sure if this has a mathematical ground. Uh, Most likely yes, because it's programming language theory. But what kind of mathematics are behind this concept? Um, you will match x with 2, and you will end with x being 2. And in here you're trying to bit string matching different sizes, so you get an error. Not typing that unless you explicitly use this modifier. Each entry in the binary pattern is expected to match a single byte exactly 8 bits. You can go deep into this topic, I suppose. That's why I wanted to do it first. If you want to know, go in like some kind of list flavor. You have 0, 1, 0, 1, and then you say, okay, I'm going to each entry in the binary pattern is expected to match single bytes. And you're assigning to x these 2, 3. There are a couple other modifiers that can be useful when doing a pattern matches on binaries. And okay, so you had rest. And then we arrive to the formal to the terminology here in Elixir about string is a UTF-8 encodes binary. Now that they have defined binaries and bit strings, now we arrive to the string concept, where the code point for each character is encoded using 1 to 4 bytes. Okay. I mean, probably this knowledge will be used in a certification exam, but I don't know if you want to memorize this. Maybe in 2010, I suppose, our memory, it shouldn't be the case, but it seems like as computing is making progress, we are feeling less and less the need to memorize, and we are probably losing the ability to memorize. I'm not sure. I'm talking from ignorance here. But yeah, let's exercise memorizing things. Hopefully, good things. Again, another of these. Every string is a binary. Not every binary is a valid string. And you have your helpers. Binary and it's a valid string. And you can ask yourself, why is the case? And you have this operator that operates on strings because they are saying that it operates on bit strings. Which was reasoned earlier. Binaries and bit string. You can also pattern match on strings. Head will be this. Remember, this is for code points. So the head will be this bit. But it's prepended with this question mark. So it's the code point value. and the rest anana. And then you have this calling in Spanish diéresis. Diéresis. I don't know the concept in English. They don't have it. Well, I haven't seen above X. Okay, more of this stuff. I don't see. I haven't seen too much open source with Elixir, but I'm not sure how pervasive are all of these. But it's good to know. Then we arrived to Charlie's with uses this sigil. Where is the his sigils? And it has its own chapter over here, and it gives you the code points. So a char list, the list of integers where all the integers are valid code points. Okay. So here it is. And then his list, and you pass this sigil. This sigil, which will convert to a char list, this string, and it will give you back this list. That's why you get a true for this evaluation. Her bits per minute, 99, 96. Cat. Now, another, okay. To a string, you have this char list, and you get this string. You are trying to concatenate two char lists. Okay. And look at this for your interview polymorphic. They accept many shapes. Okay. For your job interviews. Main list, use the list operator. Okay. Since the result for these evaluations are lists, the results, you need to use this operator. And in here you're operating on strings. You need to use this operator, which in turn operates on bit strings. Where is this guy? Here. And with binary string and Charlie is out of the way, it is time to talk about key value data structures. 28 minutes, I think we can do half an hour. Or let's put an alarm so I respect your time. Where is the clock? Where is the clock? Where is the clock? I always have this thing over here and now it's missing. Oh my god, look at this. Here it is. Let's close since it's Friday. 31 minutes. Hopefully we are going to do this very quickly. I'm not going to explain you this because like I did with the big string, hopefully, because just exercising this for myself. So clear EX, ES, EX. And now let's talk about blah blah blah. Associative data structures. The key to certain values. It's the concept is maps. and say that they are known as dictionaries hashes, but I need to revisit this topic. Associative arrays, etc. Also this. In Elixir, we have two main associative data structures, keyword lists, and maps. So memorize this keyword list, data structures to pass options to functions. Let's see a scenario where this might be useful. Okay, keyword list is to pass options to functions. You are splitting this and you're passing the delimiter and you get 1, 2, 3, 4. Okay. What if you only want to split at most 2 times? Was option to be set. And here's the thing, this is the keyword list. Keyword list allows you to pass options to functions. Now you have your string. Now you have your delimiter. Now you have the options that the function will take into consideration. And most likely this is documented somewhere. What kind of options are allowed? So remember this, you have the syntax for a list, and you have this sort of wheel like JSON. And we got 3 paths, okay. And it says, here's the list, the first element being this. I mean, you are probably saying, hey, Caleb, I know how to read and I seeing what you're saying. Tell me anything else. Tell me something else. Well, I will tell you that given these options, keyword list options of options, you get the 1 without the space, 2 without the space. And what else got modified? It only operated 2 times. So this got as it was. Look at this. Here's a different result. But we are not talking about how split operates, but the syntax for keyword lists, the leftovers. No. When a keyword list of function we can black and white. Well, yeah, you just remember that a keyword list, these options are stored in a list. When you see code, on keyword list, it's modifying the function behavior. Yes, optional arguments to functions. Okay, and here's the real deal. And in fact, they say these are tuples when the first component is an atom and then the value, which is equal. This is more convenient. But if you want to go to the core, this is the things. Mm. Case must be atoms. They follow an order is specified by you, and keys can be given more than once. And here they are using this syntax to import a string, but only split with the version with one arity and the version with two arity. Okay, this is the atom. Keyword lists are lists, so you can operate on them like this. Well, this is like a lot. This is like a lot. And here you are accessing where list is this. And in here you are accessing this atom. And it gives you the value, which is one, okay? You can do pattern matching on this, but it's not done in practice. So this is not recommended on keyword list. Yeah, you probably don't want to do that. Here's the keyword module. Take a look at this. And you have maps also. If you need to store a large amount of keys in a key value data structure. Okay, so only for a few ones you can use the keyword list. And here you just have to remember the syntax. Okay, and that's all. Just don't get too crazy about blocks and keywords. If true, do else. But let's say the if is a macro. It says do else make up a keyword list. They are nothing more than a syntax convenience on top of keyword list. We can rewrite the above to if true, do else, and this will be seen. Okay, so these things are at the atoms. This is the value. Here is the comma to separate the next element. So they are saying us that do block like this and the else blocks make up a keyword list, and you can, since you know how they work, uh, you can use it. Let us see if we can use the brackets since they are a keyword list. Well, I don't know. Really, this is a boolean value, so probably one experiment putting a bracket here. You need to. You saw how we are messing around. And then we arrived to map. And again, we saw tuples, but now you are adding this percentage to the braces and the atoms, pad arrow, and the value. And I'm going to write this to internalize everything. So it says map equals to uh, uh, 1, 2. Something fun is going on here. Because in here you have an atom first, and then the value, and in here you have some sort of a value, and then the atom. So I suppose maps in Elixir uh, accept keys of different types, you know. Okay, because here's an integer, and here's an atom, you can conclude, okay, maps accept keys of different data types. Maps allow any value as key, okay? Any value, any value. Maps have their own internal ordering, which is not guaranteed to be same across different maps. Maps are very useful with pattern matching. You're pattern matching the empty map with this map, okay? No match of right hand side value. Or this thing gets evaluated or not. Yes. The other day was something over here, and then now it's a little fellow from cat over around and meowing. How do you say that in English? In English, as general. Let me read this for you and tell it a day, alright? Because we are ending here. As shown above, a map matches as long as the keys in the pattern exist in the given map. Therefore, an empty map matches are maps. You are seeing this here. An empty map matches are maps. And where is the other thing? A map matches as long as the keys in the pattern exists in the given map. So in here, look at this. Exists. Exists. So it matches the whole thing. And you get it. And you get your A. Have a look. And you get one from here. Right? The man module provides very similar API to keyword, and you get the get method or function, and you provide a map and the key, and you get one, and then you put this value on the map. Let us exercise this. I mean, type map put, because it's important to update a map. Now I'm getting very slow because it's weekend, I suppose. I'm not sure. 1, 2, Look at this. Where is the symbol? And yet to practice and this setup. Probably on the weekend. Be the map gets close. And you got your new atom and three. And you got your map. You got your map. Now my question is, what will happen if you? Oh my! What will happen if you are trying to put the value when there is an existing key? What will happen? And the value gets updated. So it's not an error. Okay, so sure, just see. You know this from other programming languages. Here I'm seeing the syntax in Elixir and its peculiarities. And in here you can let us see the keyword list. Here's a keyword list. Okay, here's the keyword list, right? Let's try to use this syntax with the map put. Okay. And we got nothing back. Can you see this is okay? Now let us use the keyword list. I'm sorry. Where are they? Okay. I saw. I told you in the previous lesson about this syntax. Okay, now we are using this because they are switching the column. We are about to switch this the place of this and get rid of the comma. Let's see how it goes. We'll use. Oh my god! Rid of this with the comma and use a big number always. Then close the list, keyword list, and see what happens. And it says parts 3. Function that is undefined or private. Did you and it says that if you want to use pub3, which is what they are using over here. So this keyword list, it doesn't play along with matpub, but we have to try. In order to see something new, for example. And it says, did you try to use matpub3, which is the map 1, the atom, the key, or the key, sorry, the key, not the atom, key, and the value 1, 2, 3, 1, 2, 3. All right. So this will help you to understand why it is didn't quite go through. And then there is another syntax format, and it's different in the sense that you got your. There's nothing different here. There's the atom, the fat arrow, atom, fat arrow. Well, let's see what it says. Our keys can be either removed at any time. However, it also comes to create maps with a predefined set of keys. The values might be updated, but new keys are never added. No remove. This is useful when we know the shape of the data we are working with and we get a different key. It likely means a mistake was done elsewhere. In such cases, the keys are most often atoms. Okay, I think the animal around started. Their values might be updated, but new keys are never added, no remove. How would you remove a new key, right? New keys are not removed. Well, this is a new key. How will it doesn't exist in the map. This is useful when we know the shape of the data. Uh, oh my god, so we're working with if we get a different key. It's likely making mistakes. Mistake was done as well. There's nothing different here. Okay, but what I understand is that they are immutable because you're not case I've never added, no remove. Well, you have a kind of constant mode. But no, they are referring. I saw some Phoenix web framework training, and these things, the things they are mentioning here, it's useful when you are accepting some kind of JSON and you expect the JSON to arrive in certain shape, format, and you predefine what you are expecting. And if it doesn't arrive like that, if the client sends different shape, you will dismiss the web request. I mean, the function will not be called. I will refer you to a great training course on Monday in relation to pattern matching over uh, in Elixir, but it takes a great deal in the maps section. Okay, there's nothing different from this map than this map. All right. When a key is an atom, we can also access using the map keys in fact. Map name John my AG. Well, but it's not because it's H. Well, AG. There is also syntax for the updating keys, which also rises if the key has not yet been defined. Okay, the syntax is, you can see it, the braces, the percentage, the name of the map, and the name of the key and the new value. So it's not John, it's Mary. And you're trying to put this AG, but it's not present. Nested data structures. Okay, maps inside maps, keyword lists inside maps. Okay, you have a list here, a list, and you have your map. Sorry, this is a keyword list. You see, and then you have a map as a value. Another element, Okay, it says here we have a keyboard list of users with each value somehow containing the name, age, and a list of programming languages each user likes. If we wanted to access the age of John, we could write users John the key and the map key, which is age. This is feels convenient, right? Okay, this is very convenient if you have nested data structures. And we come to an end. I as you see, I didn't type too much in this section because uh, the syntax is only this. This is not part. This is not part. Then you learn that uh, you have you need a key, and then your map, which is only this percentage with a brace. And this is how you access. So not much to write unless you want to write languages, Erlang, Clojure. Uh, Also, replace this by A, B, C in order to avoid you in order for you to avoid writing things that are not relevant. The, the syntax, and someone will say, "Why don't you just consult the grammar of the Elixir and avoid us spending 1 hour with you?" Like the Bacchus now form, because these are good explanations over here. They provide very good insights and they provide access to these links. That's why there are two different data structures: keyword lists for passing optional values to functions, maps for general key value data structures, and you can use this with a predefined set of keys. And that's all. You can have nested data structures, and you can continue with me on Monday with this topic, which is quite a breeze. Uh, okay, 1 hour. So that's all. Thank you very much and have a happy weekend. I don't think I'm going to make another live today. Maybe tomorrow playing the guitar. I don't know. I'm not sure. Stay tuned in the channel to uh, stay tuned. Bye for now. Thank you very much. Have a good weekend.